Hello everyone, I welcome you. And in this video, I'm going to focus and put much concentration on acids and bases. Now, as per our understanding, we know very well that in life we've encountered what we call acids and even bases. Now, the main objective of this video, because I'm really going to focus on acids and their reactions, bases I'll handle later. I want us to define what acid is. The first focus is the definition of an acid. The second objective of this session is to give examples of acids. And the last one, I'm going to come up with examples of reactions between acids and metals. Acids, acids and metals. Now those are the three main objectives that I'm going to handle in this video. The bases I'll handle later. Now, to begin with, I want us to define an acid. So, I want us to define what an acid is. And in our definition, I'm not only going to use one definition because several people have defined acid in different ways. So, I want to use two main definitions. And in those definitions, I want you to be very attentive so that you can grasp something out of it. So, my first thing I'm going to do is the definition of an acid. And based on my definition, I'm going to use two ways of defining an acid because two people defined acids. In fact, there are three, but I'm only going to focus on two main people. The first person is Arrhenius' definition. Arrhenius' definition. And the second one was defined by two people who joined their names to form one called Bronsted and Lowry definition. Now, you have to be very careful about these two definitions because they defined acid differently. According to Arrhenius, he defined an acid as any substance which ionizes in solution to give hydrogen ions as the only positive ion. That's according to Arrhenius. And according to Bronsted and Lowry, they defined an acid as a proton donor. And as far as proton is concerned, a proton is just hydrogen ion. So these two guys defined acid differently, and we are going to see that in the ionization to justify whatever thing they were trying to say. Now, I want to give you examples of acids. Examples of acids. The most basic acids that we know, that we've always encountered in the lab. The first one is sulfuric acid or sulfuric 6 acid. The second one is nitric acid. The third one is HCl, which is hydrochloric acid. Now, these are the main. You can even talk about phosphoric acid. Also an example. Now, there are other organic acids that are not handled here. I will handle them when I'll be talking about organic chemistry. Now, if these substances were to ionize, if they were to ionize in solution, now assume this one ionizes in solution. What will happen? Meaning, I'm going to have hydrogen ions plus sulfate ions. And if I'm supposed to balance that, I'm going to have two hydrogen ions. If nitric 5 acid was supposed to ionize in solution, I'll have hydrogen ion and nitrate. If HCl was supposed to ionize in solution, similar, apply. I'll have H positive plus Cl minus. If phosphoric acid was to ionize in solution, I will have 3H positive plus phosphate. Now, from this we can see that when this substances ionizes in solution, the main thing that is given out as the only positive ion is hydrogen in both. So regardless of the type of acid. So if I go back to how Arrhenius defined an acid as any substance which ionizes in solution to give hydrogen ion as the only positive ion. So when I come back here and see, I'm confirming that all these are ionizing in solution to give hydrogen ion as the only positive ion. The rest are negatively charged ions. What about Bronsted-Lowry? Bronsted-Lowry defines an acid as a proton donor. A donor is something that donates or gives out. And a proton is hydrogen ion. So meaning even Bronsted and Lowry are right, because in all these definitions, hydrogen ions are released in their ionizations. Now, that's true according to their definitions, and those are the examples of acids that we are going to talk about here. There are several acids, but I'm only going to handle those. Now, how do acids react with metals? Reaction of acids with metals. Reaction of acids with metals. And there are key things you need to know before you go deep into this. There are key things you're supposed to know. They're necessary. The first key thing you need to know: only metals above hydrogen in the reactivity series will react with dilute acids. Only metals above hydrogen, because the key thing in a reaction is I'm expecting an acid that we have here to react with any metal. These acids that we have here, all these acids, they are supposed to react with any metal. And for a reaction to occur, that given metal must be capable of removing or displacing hydrogen in these acids. And based on reactivity series, an element that is below another in the reactivity series cannot displace a compound. So that's why we are saying that only metals above hydrogen in the reactivity series can react with dilute acids. That's a very important point that you should never forget. Next point that you should know: the more reactive an element is, or a metal is, the more vigorous the reaction will be. What do we mean here? If I'm supposed to compare magnesium reacting with HCl dilute, the rate at which magnesium is going to react with the HCl is different with the rate at which potassium, which is at the top in the reactivity series, is going to react with the same dilute HCl. So this one will be faster, more faster, and this one will be a little bit slower. So the more reactive metal is, the more vigorous the reaction will be. Now, next point that you need to know as far as reaction of metals with acids are concerned: metals that are placed above in the reactivity series. So in this, I'm talking about metals such as potassium, sodium. These metals, you have to be very careful with them. You should never react them with acids because their reaction is very explosive. They react with acids explosively. Potassium and sodium reacts with dilute acids in an explosive way. So such reaction should never be attempted in a congested laboratory, because there are always instances of fire, explosions, which might sometimes lead to injury. So it is always advised that any person who is trying to attempt this type of reaction should be very careful and should be done in a controlled way to minimize injuries. Next thing that we are supposed to know, whenever a metal reacts with an acid, they form salt and hydrogen gas. So that point is very necessary and you should be careful with it, because regardless of the type of reaction, regardless of the type of metal you are reacting with any type of acid, I'm expecting a salt and a hydrogen gas to be your products. And we are going to see that in the further examples we are going to look into. So there is always a way in which I can come up with it. So now from that point, I can come up with a general equation that whenever any metal, reacts with an acid, what I'm going to form is a salt and hydrogen gas. So I'm going to go through examples of metals reacting with acid. Examples. Examples of reactions between metals and acids. Now, I'm going to start with group 1, I go to group 2, and group 3 with various type of acids. So, I can come here and start with any group 1, with any acid. Now, I can decide to react lithium, Li, solid, with sulfuric 6 acid. But we said, anytime a metal reacts with an acid, I'm supposed to form a salt and hydrogen gas. So those are the things that I need. The first product is going to be a salt. But how do I come up with a salt? Now, if you don't know how we are coming up with a salt, this is how we are bringing it out. Lithium is in group 1, so it is going to have a charge of positive 1. It is going to react with hydrogen, hydrogen plus SO4 2 minus. This is the reaction that is happening. I'm just writing it and I'll rub it later. So this positive, if the reactivity series lithium is higher than hydrogen, so lithium is going to take the sulfate and displaces hydrogen. So when that happens, at the end of the day, I'm going to form now the product. So I want you to see how that is now coming in. So I'm supposed to have a sulfate of lithium. So the sulfate I'm going to form looks like this. It's going to be Li2SO4 plus hydrogen gas. Li2 plus hydrogen gas. Now we are supposed to balance it, and to balance it we must come up with a number. So I have two lithium, So the only key thing that I need to do here, because sulfate is 1 here, hydrogens are 2, hydrogens are 2. Hydrogen is balanced. Sulfate is 1, sulfate is 1. So the only key thing I need to balance is this area here to make this one also become a 2. So when that happens, now I'm going to put a 2 here, and my equation is properly balanced. Now there's a hint I wanted to see. So imagine a situation whereby I've decided now to react with sodium, still in group 1, sorry. Sodium is going to be Na solid plus sulfuric acid H2SO4. The same is going to apply. Going to have Na2SO4 plus hydrogen gas. Now this is aqueous because it is a soluble salt. This is aqueous because we are dealing with dilute acid. Now, so if I decided to balance this, the same rule is going to apply here. I'm having hydrogen 2, hydrogens are 2 this side, so hydrogen is balanced. Sulfate is 1, or you can even say sulfur, then oxygen are 4. So sulfate is also 1 here. Now the only thing that I need to balance is sodium, making it a 2 here. So I'm going to look for a number that when I put, so it's going to be 2 because the same reaction is happening there. So what have you realized? When metals in the same group react with the same acid, their balancing is the same. Their balancing is the same. Now let me try a group 2. Group 2. Now I'm going to react magnesium. I'm going to do magnesium. I'm going to do magnesium. Reacting the phosphoric. Now phosphate is a radical of valency 1. Sorry, is a radical of valency 3. There's somewhere I placed something which is supposed to be 3 minus. Yeah. 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 Thank you. Supposed to have a 3 minus here. Yeah. Sorry for that. I've corrected it. So when I come here, phosphate is going to be react with the magnesium. So I'm expecting magnesium and phosphate to come together, and I'm supposed to get a product. So my product is going to be magnesium phosphate, which is Mg. But remember, when phosphate is coming in, phosphate is radical with valency 3. So magnesium has a 2 positive valency plus a phosphate which is PO4 3 minus. So when they interchange their valencies, the 3 in phosphate comes here and the 2 comes here. So how am I going to write that chemically? You have to be very careful how you write it. It is going to be written as Mg3, but you put PO4 in bracket 2 magnesium phosphate plus hydrogen gas. Now, how do I balance that? How do I balance that? I look for a number that when I put there is going to give me same number of. Now magnesiums are 3. Magnesium is 1 this side. So want to balance it, this is how I start. This side, magnesium is 1. Here we have 3 magnesiums. Hydrogens are 2, the other side, hydrogen is 3. Now, imagine a situation whereby I've placed a 2 here. If I put a 2 there, hydrogens are going to be, I want us to go slowly so that we understand whatever thing that is happening here. Be very careful of whatever thing that is happening here. So, hydrogens are going to be 2 times 3, which is equal to 6. How do I make hydrogens this side 6? By simply putting a 3. Now, when that happens, how many phosphates do I have? Phosphate is balanced because this 2 affects the number of phosphates that we have. So they're also 2. So, but this side we also have 2 phosphates. So they are catered for in that. Now, next, magnesiums are 3. So I simply bring in a 3 here. Then it is balanced. What if I try magnesium, calcium with sulfuric acid? Still in group 2, calcium, solid, reacting with sulfuric 6 acid. What will happen? I'm going to have calcium, sulfate. Both are in group 2. Sulfate has a 2 minus, calcium has a 2 positive, plus hydrogen gas. So if you check very well, this one is properly balanced. It's properly balanced. So when it is properly balanced, you don't really need to worry about it. Your work is just to finish it. Finish the reaction and see. So this one is a solid, this one is aqueous. This one is also aqueous because I'm dealing with dilute acids here. Rarely do we do reactions with conc acids because conc acids are very toxic and they react explosively with certain metals. Now, that's properly balanced. And lastly, I'm going to do a group 3, which is aluminium. Let me try aluminium solid with HCl because I haven't reacted anything with HCl. Then I'm going to do aluminium with nitric acid. Now, with HCl, I'm going to have AlCl3 because aluminium is in group 3, chlorine is -1. So that one is going to give me H2 gas. This one is going to give me aqueous. Now this one is aqueous because I'm dealing with the dilute acid. So I'm going to rub this. Then how do I balance it? Chlorines are 3, then hydrogens are. So I can decide that I'm going to have a situation whereby I want to make chlorines be 3. If I want to make chlorines be 3, because this side I have 3 chlorines. So I have to make chlorines 3 this side. How am I going to make them 3? That's the question that you're supposed to be asking yourself. Because aluminium is 1, I only need to balance chlorine and hydrogen. If I want to balance chlorine and hydrogen, what I'm going to do is I look for a number that when I put here will ensure that my chlorines are sorted. So let me try, because it is a learning session. I'm trying a 2. A 2 will balance hydrogen but will not balance chlorine. So a 2 cannot work. Let me try a 4. A 4 will balance. So meaning, if you check very well here, I'm supposed to start with a value that will make my chlorine here be an even number. So I can bring a 2 here. If I bring a 2 there, chlorines are going to be 6. So it is easy now to balance it because when I put a 6 there, I'm going to bring in a 6 here because chlorines are now 6. I'm going to put a 6. Hydrogens are going to be 6, so I simply bring in a 3 here. Then I bring in a 3. I'm going to put a 2 here. So if you check very well, all those substances are balanced. Okay, that's balance. That's how balancing is done. You simply just joke with numbers until you get the most appropriate number that can fit in that given scenario. Now, lastly, I'm going to do aluminium solid with nitric. I haven't reacted anything with the nitric 5 acid. So let's see what we have with the nitric. I'm going to have aluminium nitrate. So it is going to be Al, then in bracket NO3 into bracket 3. Then plus hydrogen gas. Hydrogen gas. So how do we balance that? Nitrates are 3, hydrogens are 2, the other side. So I have to look for a number that will fit in very well and give me a balanced equation. So look for a value that we can joke with around until we ensure that our system is balanced very well. So the same is also going to apply. I simply bring in a 2 here. When I put a 2 there, nitrates are now 3. So I need a nitrates are now 6. I need a 6 here. I need to put a 3 here to ensure that hydrogens are 6. And I simply bring in a 2 to ensure that aluminiums are balanced. That's the simplest way to do reactions involving metals and acids. And I've done various types of examples across the metallic groups to enable you understand different types of reactions and how they occur. Thank you very much. And that's what I had for this session. In my next session, I'll be talking about now bases and how they react with metal, with the different types of metals. Have a wonderful time.